Dear aspirants, welcome to my channel. This is a model question paper 1, Concepts of Mechanical Engineering 2. Subject code is 25ME21I. This is in second semester. So we are going to learn part D section 2. These are the 10 marks questions. So if you attend 3 questions, you will get hardly 30 marks. Okay. The first question, which heat treatment process ensure the both strength and surface hardness for engine components justified with the process details and property changes. So before going to do this both high surface hardness and core strength, this combination of the case hardening, carbonizing, quenching and tempering methods we are going to use. We'll learn one by one. In carbonizing also we call it as an case hardening. So how the process which will be takes place, coming to the process detail. So what we have to do, steel component heated about 900 to 950 degrees Celsius in a carbon rich environment, and after that the carbon diffuses into the surface layer. It is followed by quenching, that is we call it as a rapid cooling. For what is the result which will be formed after this process? So the formation of odd outer layer case in core remains soft and tough. So next method, coming to the quenching or tempering. In this method, coming to the process detail, after carbonizing, the component is quenched in to increase hardness, then tempered at a lower temperature and to reduce the brittleness. What is the result in the quenching and tempering method? So what we have to achieve here, to improve the strength and toughness, relieve internal stress and maintain required hardness with a reduced brittleness. All these process, what are the properties we are going to achieve, or what are the properties you are going to change the properties achieved. One is in surface hardness. It means first is surface hardness. It means to improve the wear resistance. So next will be in strength and toughness score to absorb the shocks and blows. And third one is improved fatigue strength, nothing but suitable for repeated stresses. Next will be in better wear resistance, means increasing the life of the components. And not last but not the least, the reduce the brittleness due to tempering. So coming to the applications where we have to use, we can use it for engine components like a gears, camshafts, crankshaft and piston pins. So all these, what is the final, what you will achieve? The combination of carbonizing and quenching and tempering provide a hard wearing resistant surface, and it will give a strong tough core which is essential for engine components to operate under the high stress and friction. So coming to the next question, in a casting company faced a dimensional inaccuracies in a product, how would you proper selection of the patterns, materials and allowance solve this issue justified with an example? So coming to the what do you meant by dimensional accuracies? So in these dimensional accuracies, the shrinkage, deterioration and size variations can be minimized by the proper selection pattern of the materials and correct the pattern allowances. So coming to the first thing, select the pattern material. So we have to select which type of the pattern material we are going to use. So coming to here, the pattern material should be dimensionally stable and wear resistant and accurate. So in that wooden patterns, in this wooden pattern, it is a low cost, easy to shape, can absorb moisture, may warp and lose accuracy, and suitable only for a small batch production. And next will be in metal patterns. In that metal pattern, we are using cast iron and aluminum. In this cast iron and aluminum, so high strength, it having a excellent dimensional stability, resistance to wear, maintain size in a long time, used for mass production with a high accuracy. So coming to the plastic patterns, with a lightweight and smooth surface finishing, better accuracy than the woods, less maintenance, but using a metals and plastic patterns to improve the dimensional accuracy and inconsistency. So next will be in pattern allowances. In the pattern allowances, which will be provided compensating for the changing duration during casting. So in that, shrinkage allowance. In the shrinkage allowance, the metal contract during cooling. The patterns may be slightly larger. Example, steel cast need a higher shrinkage allowance than aluminum. And next will be in machine allowances. Here extra material which will be provided for a finishing operations ensure the final dimension after machining. Next will be in craft allowances. The small tapering is given for easy to move the pattern from mold and prevent the damage to the mold cavity. The next allowance is deterioration allowances. In this deterioration allowances, the given compensation for a wrapping for a complex shapes. How I have to justify it with an example. So if the steel casting is made without shrinkage allowances, the final product become smaller than what you have required. Now coming to the using the metal patterns with a proper allowances ensure the correct dimensional means correct final dimension. And next, without draft allowances, the mold damage and inaccurate shapes, you will get it. Next will be which sheet material operations and gauges are suitable for core body panel justified your voice. So coming to the core body panels, the selection suitable sheet material for operations, gauge, thickness is very important to achieve. Why these are all important? We have to achieve the strength and smooth finish and lightweight. So how you are going to explain the core body panel with the sheet metal? So we have to use a suitable sheet material operations. The first one is a blanking. What do you have to do in the blanking? So cutting the flat sheet into a required shape like a door, bayonet, roof panels ensure accuracy size being formed. Next coming to the punching. In that punching, metal holes for bolts, rivets, fittings. It is used for a door panel and wood, etc. Next will be in a deep drawing. In this deep drawing, used for a complex curved shape like a car doors and fenders, help to produce a seamless and strong panels. Next coming to the bending. In this bending, used to create a edge and flange and stiffness and improve the rigidity panels. Next is a stretching forming. So in the stretch forming, reduce the large smooth curved shape like a car roof and body sides, give the better surface finishing without wrinklings. Okay. Next is embossing. In this embossing, add a design patterns or rips, increasing the strength without increasing the thickness. Next will be a suitable gauge and suitable thickness. What type of the thickness you have to use? In the core body panel, generally we are going to use a thin metals. Okay, thin sheet metals. The typically range. What is the range? 0.7 mm to 1.2 mm. Common gauge numbers. What we have to use? 22 gauge. So it is 0.8 mm for doors and side panels. 20 gauge 1 mm for a bonnet and roof, and 18 gauge which will be 1.2 mm. It is area needed more strength. So coming to the material, what are the material commonly used for that? We are using for a metal steels, galvanizing steels and aluminum steels. Why we have to use a galvanized steel? For it is resistance to corrosion. Why we have to use aluminum, which will be lightweight in a vehicle? So coming to the justification for particular choice, why we have to prefer, now first is a lightweight, the weight. Thin gauge reduce the overall vehicle weight and improve the fuel efficiency and performance. Next will be a good formability. Keep operation like a deep drawing and stretch forming allow a complex shapes and essential for a aerodynamic designs. Next will be strength and rigidity. It is used for bending, embossing, increasing the stiffness without adding a weight and prevent the vibration and deformation. So next will be in surface finish. In that surface finish, stretch forming gives a smooth surfaces important for a painting and appearance. Next will be an cost efficiency. In the cost, the thin sheets reduce the metal cost and mass production operations like a blanking and punching, and it is an are economical. And corrosion resistance used for coated sheets like a galvanized sheets